Okay, again, what we did last time with partial fractions, we had this. We'd say this is something over x plus 2 plus something over x minus 5. You know when you put this over a common denominator, you're going to get a denominator of x plus 2 times x minus 5, right? And in the numerator, it turns out you're going to get ax minus 5a and bx plus 2a plus 2b. Okay? You pull that together, do what you were assigned for homework, and you find what a and b are so that you can write this in this form. Okay? Up here, going to be a little more involved. You're going to get more than 2 equations. Okay? So we're going to say, okay, well here, let's see. We're going to have something over x minus 3 plus something else over x squared plus x plus 3. Okay? And what we're going to do is we're going to say, we'll see why in a minute. We're going to say, okay, I've got a over x minus 3. That's going to be fine. Now I'm going to want b over this, but that's not going to be enough. Okay, for reasons that I'm not going to try to explain right now. I'm going to make this ax, instead of just b, I'm going to write bx plus c here. Okay? Okay, well, it's not difficult, except we got 3 variables, right? A, B, and C, we're going to have to get 3 equations, but we've learned how to do that, hopefully. You get more practice, because I'm going to assign some of these. Okay? Common denominator is very simple. I didn't leave myself enough room to write it so you can read it, so let me fix that. This is going to equal a times x squared plus x plus 3 plus x minus 3 times bx plus c. No matter how much room I give myself, I'm going to get jammed up at the end. It's just the way my brain's wired or something. And that's over x minus 3 times x squared plus x plus 3. Now everybody should understand that because, again, we did the stuff with fractions early in the course and people were pretty good at it, so you might have to review a little bit, but I think you should be pretty good at it. So it should be pretty easy to go from here to here. And that should be pretty easy to go from here to the next step. You'll probably want to use a distributive law over here. But I'm going to skip that step because I know you know how to do that. All you got to do is remember that you got to do that, right? Okay? So we're going to have ax squared. We're also going to have a bx squared. And we're going to have an ax here, and we're going to have a negative 3b plus cx. And then it's going to be plus (3a) minus 3c, all that over x squared, x minus 3 times x squared plus x plus 3. Now this is getting in my way, so I'm going to get rid of it. Have that up there to reference you to what we did last time. Those of you might not have had time to get it all done. It was due, so you should have gotten it all done. But. Okay, well, they have the same denominator, so the numerators have to be the same. So x squared plus 1 has to equal a plus b x squared plus a minus 3b plus c x plus 3a minus 3c. I don't really need parentheses there, but they're going to be on this one. I need them up here. They're going to be helpful. So what's this say? What does a plus b have to equal? What's a plus b in front of here? What comes after the a plus b? Somebody read it to me. I know. X squared. Okay? I thought y'all were able to read. Yeah, obviously you are. You're just kind of smiling. Nobody wanted to say it. Okay. Okay, so a plus b is in front of x squared. What's in front of x squared over here? Yeah, don't say nothing. Because a plus b has to equal whatever is in front of this. It's more literate to say the coefficient of x squared is a plus b. On this side, the coefficient of x squared is 1, right? Anticipating that I'm going to have 3 simultaneous equations, I'm going to leave myself room for a c. We don't have a c there, so we don't have to write it. Okay? Okay, what's in front of x over here? What's the coefficient of x? Well, I wrote it nice and big. You should be able to read it, but maybe not. A minus 3b plus c. Okay? You find the coefficient of x right in front of x. And you know that. Okay, so we have a minus 3b plus c. Okay, what's the coefficient of x on this side? 0. Which is why we didn't even bother writing it down, but it's there just with a coefficient of 0, so we don't really have to write it. Okay? The only way this is going to equal this is if this is 0, so we don't have to write the x term, right? There's no x term over here. Okay, well, then whatever's left has to equal 1, and that's just the 3a minus 3c equals 1. Well, that looks a whole lot like a lot of systems that you've solved for the flow model, but the numbers are much, much simpler, aren't they? So it should not be difficult to figure out what A, B, and C are. Okay? Okay, this is part of the technique of partial fractions, which is a topic that our course description, officially published, doesn't include, but which our more extensive syllabus that we're directed to follow does. In other words, it's something we need to include, even if it doesn't necessarily look like it. Okay? So, partial fractions. It's really a pretty simple procedure. You factor your denominator, whatever the factors are, you do this. Okay? If you've got a quadratic down here, then you got to have a linear up here. Degree of this has to be 1 less than the degree of this, right? That's all. And then you just write it down, do what you know how to do, separate out your equations, and solve them. I'm not going to solve them. Yeah, we've been over solving systems equations many times. But what would you do what's the first thing you do in order to solve this? I see two good choices.
Let's try that again. Divide the middle one by negative.
Do what now?
Divide the middle by negative and put it against the top one.
Divide the middle one by negative.
Specifically negative.
Not sure that's exactly how I'd say it. Why would you do that?
Put a.
I mean, there could be a good reason. You got one?
Put a is negative and. Well,
Okay, if you wanted to make that a negative so you could match it up with the 3a, you could do that. Of course, you got c's over here, one of them's already negative, right? So, but if you want to pick on a first, you could do that. You can multiply this by a negative, but I'd multiply it by, okay, if I multiply this by a negative and add to this one, I'm going to get rid of a, right? Because I was kind of looking at c, so I was looking at these two, so you know, you didn't tell me you wanted to match it up with this one. You said you're going to match it up, right? Well, that's okay. That's a good answer. Okay, so we multiply this by -1, right?
Specifically, yes.
You didn't say negative what either, but I know what you meant. And then add it to this, we're going to eliminate a, aren't we? Okay? We'll eliminate a from this one. Then we could eliminate a from this one, but using these two, we could eliminate a. Okay? Then we'd have two equations in B and C. And one of the equations would be, well, no, neither one would be all that easy. Okay, but main thing I'm saying is you just use the process of elimination, the technique of elimination. And I hope everybody knows that elimination doesn't mean you just don't write it down next time. Okay, it means you eliminate it mathematically by adding the right multiple of one equation to another, right? I think we're kind of okay on that, but we probably need a little more practice. So you see, this whole process of solving simultaneous equations comes up again and again, right? Okay? If you want an exponential function through 2 points, you're going to have to write down two simultaneous equations and solve them. Power function through 2 points, two simultaneous equations and solve them, right? Quadratic function through 3 points, write down three simultaneous equations and solve them. Very important technique. Find out where two straight lines intersect, write down their equations and eliminate a variable, right? Find the other variable, plug it back in, find the first variable, right? The one you eliminated. Okay? So that's a process you've got to be kind of good at. And hopefully now, after we wrap up a couple more things, be able to spend a couple of weeks pulling everything together in such a way that everybody can make at least A minuses. Everybody's capable of it. Okay? Never had it happen, but I was able to get 5 A's first semester. How many of you are there? See, there aren't as many of you, you know, see, got a better chance? I don't know. We'll see.